Let's prove that if this equal to this, then dy dx equal to this. Now we're going to solve this using the shortcut formula for the quotient rule. And by doing that, we let u to be x, u equal to x, and v equal to y. So we differentiate and put in the formula so that v du, our v is y dot u, differentiating u, which is x1, minus the minus sign, then u dv, u is x, dot differentiating y, we have dy dx all over v squared, which is y squared, then multiply by the same thing, e to power x all over y, equal to differentiating the right hand side, differentiating x, we have 1, minus differentiating y, we have dy dx. Now, in this case, we're going to multiply through by y squared. This multiplying this, we have 1 dot y is y minus x dy dx multiplying e to power x all over y equal to y will multiply this y squared minus y squared dy dx. Now, in this case, we're going to make dy dx the subject. And by doing that, we expand the bracket y dot e to power x all over y minus x dot e to power x all over y, then dy dx equal to y squared minus y squared dy dx. Now we're going to collect like terms in dy dx. So this will come here. We have y squared dy dx minus x dot e to power x all over y dy dx equal to, now we have this already, y squared, and this we move to the right hand side, minus y dot e to power x all over y, so that we factorize dy dx into y squared minus x dot e to power x all over y equal to y squared minus y dot e to power x all over y. Now we divide through by this so that only the y dx remain. We have dy dx equal to y squared minus y dot e to power x all over y all over this y squared minus x dot e to power x all over y. So we can factorize the numerator. Therefore, dy dx equal to y will come out, then y will remain minus e to power x all over y squared minus x dot e to power x all over y. And that is the proof.